At the moment, the university is very keen to invest in polymer sintering. It's used in applications from everything from Formula One through to consumer goods, high fashion. So the process starts at the CAD stage. Kurt over here is actually just positioning and orientating the parts within the build volume. Over to my left, Wendy's now working on the slicing stage. So taking those CAD models, slicing them into thin layers, about 1/10 of a millimetre in this case, ready to transfer them over to the machine. Over here is where the magic happens. Basically, we deposit a layer of powder, in this case nylon 12, preheat that to just under the temperature that the polymer melts at, scan that with a laser into the required cross-section, deposit another layer of powder, keep on building up until we've got the completed part. So at the end of the build, we're left with the parts encased in this, what we describe as a cake of powder. We let that cool down, take it over to the clean-up station, and basically remove all the loose powder from around the edges of the part.
So the component that I had produced using the laser sintering is part of the intake manifold assembly. As you can see, it's quite complex. It's got lots of parts that intersect with other parts. We've got mounts for it connected to other parts of the manifold, mounts for it to bolt into the engine, and mounts for the fuel injector rail. And all these parts can be integrated into a single component because of the nature of the process. So this is the part on the whole car, and this is the whole intake manifold. It comes down from here where the air comes in, this large expansion here, and then into one of the primary runners which you just saw, into the engine. Performance should be improved, certainly compared to previous years. It'd be incredible if we won. We are aiming to win some of the design events, but everyone's pushing for it. You know, a lot of late nights. Because of additive manufacturing, we've definitely got a better chance of winning this year.
So we've seen that the laser sintering process can make geometries that are impossible to make any other way. However, one of the disadvantages with laser sintering is that it takes a long time to make parts, especially when there are a lot of parts or they're big parts, because the laser has to scan backwards and forwards. So we've addressed that problem by putting a print head onto the machine. And what we do is we print infrared absorbing ink onto the powder bed surface. After we've printed the ink, an infrared lamp passes and the energy from the lamp is absorbed by the ink and melts the powder particles underneath. We then come back and deposit a fresh layer of powder over the top, and we repeat the process. What this allows us to do then is to make parts much more quickly than we would do with a laser. So we're developing the technology here at Sheffield. We're trying to experiment with the process, working with different materials, and we're also speaking with a number of different companies who have an interest in taking this to a commercial outcome. One of the beauties of this kind of technology is that it can be applied to various different sectors. However, to me, I think the aerospace sector and perhaps the automotive are obvious places to start, but also consumer products. Perhaps being able to make personalised footwear, for example, might be a nice way to use the technology.
So one of the application-based projects that we've worked on was looking at running shoes. And we looked at that over the whole cycle, so from performance athletes, if we could enhance their performance perhaps by varying the stiffness of a shoe sole, all the way through to the general public, and basically, can we improve the safety and comfort of shoes for everyday people? One of the other aspects obviously with that is we can get in increasingly complex aesthetics into the shoes as well. So we combine the function with actually something that looks good and that people want to go out and buy. So with a view to expanding the range of materials for polymer sintering, one of the things we're doing at the moment is setting up a consortium of companies. So this comprises of end users to tell us what industry needs in a material, material manufacturers to actually produce and refine those materials, and our expertise kind of sat in the centre of that to steer the development of new materials for the market. What we would say is, if anyone out there has ideas for projects or you simply just need some advice, please don't hesitate to get in touch.